over cosine. We could deal with that by getting rid of this fraction within a fraction by multiplying by cosine. I don't know if that's necessarily what I would do next, but I guess we'll see what happens if I multiply this by cosine over cosine. What we would get is what? On the top, we'd get 1 minus cosine squared over sine cosine. Right. Cosine of x times 1 over cosine is just 1, because the cosine divided by cosine is just 1. Cosine times cosine is just cosine squared. And then the denominator, right, it's just sine times cosine. And actually, I think then what you want to look at is this right here. Okay. What does that look like?
Let me look here in my notes. It's been a while.
A squared is the key part there. Having a 1 and a squared, there's an identity that involves that.
The Pythagorean?
That's right. Yeah, the Pythagorean, right? Sine squared. Oh, God. Okay, sine squared plus cosine squared is 1. And so, okay. So if I notice that if I subtracted cosine squared from both sides of that, what we would get on the left is sine squared of x. And on the right, we would get 1 minus cosine squared of x, right? So instead of 1 minus cosine squared of x there, I could put sine squared. So that would be, okay, next would be sine squared over sine cosine. And then we could do that same trick we did before, right? We've got a sine of x in the numerator and the denominator. So we could cancel out. That'd leave us with sine over cosine. And what is sine over cosine?
Tangent.
Yay! There's probably a quicker way to get that. But, I mean, as long as you get tangent of x as your final answer, the particular way you do that doesn't really matter. Okay, did you want to go over 3b as well?
Yes, please.
Is it all right to clear this, or do you still need some time? Okay.
I have it.
All right. So, what do you think we should do first for 3b?
Get the secant into sine and cosine.
Okay. What is secant in terms of sine and cosine?
1 over cosine.
Yeah. Okay. I'm going to continue that work. I'm going to try doing it this way. See if I can give myself a little bit more room here. Plus 1 over 1 minus cosine over sine. Okay. What do you think we should do next?
Make them into like multiply.
Yeah, multiply them. Start simplifying here and getting rid of some terms. Okay, so if we double distribute, we got 1 over cosine times 1. 1 over cosine times cosine, or negative cosine, well, that would just be negative 1, right? Cosine and cosine will cancel. All right, and then my second term, 1 times 1 is 1. 1 times negative cosine is negative cosine over sine. And then if you combine like terms here, right, negative 1 plus 1 is 0, so you get this. And now if you look back at our previous problem, I bet you could take this the rest of the way, because this looks like a step that we got in part A.
Yeah.
So yeah, the next thing you'd want to do is multiply everything by cosine to get rid of that fraction within a fraction. You should notice that there's going to be a Pythagorean, or that you can use the Pythagorean identity. and then you'll be able to like cancel some stuff out and then use a identity to find out what it is. Did you say you needed number 4 as well?
Yeah.
Okay. Good to clear this?
1 sec.
Okay. Let me know when you're ready.
Okay, I'm ready.
Okay. Cleared. Oh, clear. Okay. 4. You want to do A or B?
Both.
Okay. So for number 4, A here, this one you should notice looks like it's in quadratic form, right? It looks like it's in ax squared plus bx plus c equals 0, or at least I can make it look like that because it's got this cosine squared and then it's got a cosine that's not squared and then a constant. So what I would do, I like keeping my leading term, the x squared term, positive. So I'm going to subtract 2 cosine of theta and 1 from both sides. Ooh, both sides. And you'll get cosine squared theta minus 2 cosine of theta minus 1 is equal to 0. And basically how you're going to solve this is the same or very similar to the same way you would solve x squared minus 2x minus 1 equals 0. The only difference is at the end of this, when you get, x equals blank and x equals blank, is instead of x, it's going to be cosine of theta equals blank and cosine of theta equals blank. So whatever techniques you would use to solve this one are going to be the same that you would use to solve our cosine squared one. You just have to make sure at the end it's not x equals, it's cosine theta equals, which means you'll have an additional step where you have to take the inverse cosine of whatever. So let's go ahead. Yeah, let's do it. We'll at least do one of the factors. So for this one, how would you like to solve that? Would you want to factor it or quadratic formula?
You could factor, can't you?
Yeah, you could. What are the 2 factors going to be? Yeah, Lincoln? Oh, you found it? Yeah, that calculator is definitely not going to work, Lincoln. That's old. Yeah, that's a Lincoln toy now. 9:15 or 10:50. No, what did I say? 9:45? Yes, 9:45. Lincoln. Okay. What'd you get for your factors?
Can you factor it?
Yeah, you can factor it. You're looking for what multiplies to be -1, right? And adds, oh, what am I, that's, I don't know. How am I writing that? Yeah, you're looking for what 2 numbers multiply to be -1, but add to be, oh shoot, no, you can't, can you?
No.
Oh no. Because what, like if you try -1 and +1, those won't add together to be -2. Huh. Oh, well, that's okay. All right, so if we can't factor it, what do we do?
Quadratic formula.
Yeah. Wonder if that means that I wrote the problem wrong, because I think this one you were supposed to be factoring it. But whatever. All right, quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so if we plug this in, oh golly, I'm not going to have enough room over here. Maybe. We'll see what we can do. All right, so that'll be what? X is equal to positive 2 plus or minus square root of negative 2 squared minus 4 times 1 times negative 1 over 2 times 1. And then that would be what? 2 plus or minus 4 plus 4 square root of 8 over 2. Okay, so then that would be x would equal, I'm going to continue that over here. What? We can make that 2 square root of 2.
Mm-hmm.
And then that's what? Just 1 plus or minus the square root of 2, which I guess we can really just turn into 2 decimals since we're going to get decimal answers at the end of this problem anyway. So that means that if we do 1 plus the square root of 2, 1 plus square root of 2, 2.414, and 1 minus square root of 2, get negative 0.414. Okay. So now what I was saying, all that work is really at the end of our problem, what we're going to have is the cosine of theta equal to those two things. So we're going to have two equations that we need to solve. We're going to have the cosine of theta is equal to 2.414, and the cosine of theta is equal to negative 0.414. And then you're going to want to solve both of those by taking the inverse. I don't know if I love my notation here. I think I'm going to get rid of those subscripts until we have to actually find our two answers. All right, for this first one, note that your calculator should be in degree when you're doing these. So if we make sure the calculator is in degree. Oh, golly. We're going to take the cosine inverse of, and these calculators, you can just go up and copy the answer that you got previously. That way you'll reduce your rounding errors. And you'll notice that that one is not in the domain because the ratio that we're taking is greater than 1, and it's impossible for your x value to be greater than your r value. So for this one, you would say no solution. For this second one, you'll do the same thing, and you'll tell me what the first solution is, and this one you will get a solution for. And remember that that is going to be the answer in quadrant 2, and you will have to find in what other quadrant is cosine negative, and then what the answer would be in that quadrant. And you can check your answers by plugging them back into your original equation here and seeing that it satisfies it. You could also go to desmos.com and graph the cosine squared of x and the 2 cosine x plus 1 and see where they intersect between 0 and 360 degrees. Does that make sense?
Yeah.
Okay. That's a tough one. I think that's probably, that was number 4 as equivalent on the Unit A test was the most missed one. So if you get that one, I think you'll be fine for this unit or this lesson. Is it good to erase this and we could start on 4B?
I'm ready.
Okay. 4B. So the idea here is this is not of quadratic form, but you can solve it. by first getting all of your trig functions onto the same side of the equation. So I'm going to subtract 2 sine of theta from both sides. Okay, and this is not a quadratic form, so you're going to solve it by factoring it. Notice that these two have a common term, sine of theta. So you can factor that out, and what you'd be left with is secant theta minus 2. And then it's just like where you left off on the previous problem. We're going to set those factors equal to 0 and solve both of them.
Okay.
By, for this one, you can take sine inverse. For this one, you'll add 2 and take the secant inverse. One thing, when you're doing that for this one, when you're taking the secant inverse of 2, remember that's not like your TI-84 there doesn't have that as a button. So how you would want to type this in is the cosine inverse of 1 over 2. And again, that is going to give you, that'll give you the answer for that one in the first quadrant, and you'll have to find in what other quadrant is cosine positive. Does that make sense for that one?
Yeah.
All right.
Oh, I also have another question about the next lesson, 9.1. Number 5. I got everything but number 5.
Okay. Let me pull that up. Oh, number 5? Oh, yeah, that's a challenge question. That's good. You got all the other ones. Okay, number 5. All right, here is the hint I'll give for number 5. So, and this, you have to recognize that since EC and ED are tangents to circle A, that means that this is a 90-degree angle and this is a 90-degree angle. If you connect the A to E here, what that will do then is split this into 2 right triangles. And if this angle, whole angle is 42 degrees, then I bet you could tell me what this angle is then. And then use this right triangle here to find EC, given that AC is 6. So if you just pull that part out, what that right triangle looks like is this, or again, this is 6, and you need to find that side right there. So then you can now follow the same steps where you say, okay, which is my opposite side from my angle? What is the adjacent side? What is the hypotenuse? And then what equation relates my given to what I'm trying to find, right? And then it's just like the problems above.
Okay.
And then you could use the same technique to find the ED.
All right. Thank you.
No problem. All right, any other questions?
No, I think that's it.
All right, cool. Well, thank you all for dropping in this morning. If you have any more that come up, feel free to email me, or I'll have office hours tomorrow as well from 9:30 to 10:30. That's a free-for-all.
Okay.